Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fiazi. So today I would like to present introduction for our mini project. So we are now predicting student performance using machine learning. So it's for review of research papers predicting advanced performance using machine learning techniques. So there are two algorithms that we use in this mini project. That's why it is the final grades we multi-level perceptron NLP, and then we also categorize students using training clustering.
Hello, so I will present our chosen algorithm and justification. So we have choose two algorithm which is multi-layer perceptron and clustering. So for multi-layer perceptron, it is a artificial neural network that used for regression task. So why we choose multi-layer perceptron? Because it had it has an ability to learn a complex pattern. It use multi hidden layer allow it to capture relation that simpler model cannot do. So this is useful we when we deal with dataset dataset that contain variety of factor. So then it provide a high accuracy in predicting continuous value, which make it is an ideal for predicting final student project. So 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 to summarize it, multi-layer perceptron is a flexible algorithm. It has the ability to handle large data and a good accuracy for this project. It is a good choice to predict the final grade in for student. So next for K-mean clustering. So K-mean clustering is to identify distinct performance group for this project, such as excellence, good, average, and at least student. This will allow us to understand different performance level for each student. And so why we choose K-mean clustering? Because the algorithm is effective for clustering, especially when the data does not have the predefined label. It is efficient. It efficiently partition data into group based on similarity. With K-mean, we can easily identify pattern in student data, such as student who consistently perform versus with student that with underperforming. So we also use K-mean clustering to by selected to cluster based on Elbow method and then label this clustering as excellent, good, average, and at least. These categories help to tailor intervention and academic support to meet the specific need of each group. So, K-mean clustering is highly effective in a supervised setting, allow us to identify distinct student group and analyze how various factors relate to each student performance. So that's all for algorithm and justification. Thank you.
Hello, my name is Ali Arif bin Anwari, and now I will be presenting about the project implementation process. So, we start the implementation by the first step is data acquisition. The source is from the UCI ML repository. Using the UCI UCI ML repo. So the dataset used are the student performance. And then we will do the second step, which is pre-processing, which is the label encoded categorical columns, skilled numeric features, and the target is G3, which is the final grade. So it will prepare the data for machine learning. Algorithm requires numeric and standardized input. And then the step three, exploratory data analysis. It is uh, it is to summarize the stats, and it shows the histograms and box plot for G3 and heat map for future correlations. This is to understand the grade distribution, check data quality, and identify relationships with the target variable. And then we will start training the algorithm. The first step is MLP regression model. It is a neural network with three hidden layers, and it's trained on scaled data to predict the target, which is GP. So uh, the output of the MLP regression model is the predicted G3. And then the next step is K-mix clustering, the next algorithm. So we will use the algo method to find the optimal K equals to 4, and it will cluster students using performance related features and label the clusters by performance tier, which is excellent, good, average, and at risk. And then the sixth step, uh, combine prediction function. We will take a new student's data and predict. It will predict the grade using MLP, and it will assign the student to each cluster using the k-means. So the output will get the student grade, the cluster, confidence, and error. So lastly is the summary. It will show the matrix report clustering inside. Uh, and it will show the test R squared with in approximate value. So that's all for me. Thank you.
So in this section, I would like to discuss about the result based on the two approach that we use, which is the multi-level perceptron and the k-mean clustering, and also a discussion followed by a discussion. So first of all, as you guys see here, we use the multi-level perceptron model, okay, to train on the student performance dataset, uh, which we evaluated using the MSE, mean square error, MAE, mean absolute error, and the R square. So if you look at the training result, the R square value is 0.996, indicates that the model was able to explain nearly 100% of the variance in the training. Okay, so the low value of the error indicates that it fits the training data very well. However, when we look at the testing result, the error value increases and the R square value drop to negative value. This shows that there is a indicates that a worse performance here. So what happened here is that an overfitting occur. So this means that the model learn through the training data very well, but is unable to generalize new data. So how do we overcome this problem is using cross validation and also generalization. We use the k-mean clustering approach. So here we group the student into four groups, which is the good performer, excellent performer, average performer, and at-risk student, depending on their grades. Okay, so by doing this, we can identify student that need help and for proper help to be given. So all in all, based on the MPL, we see that it can read the training data very well, but we need further improvement on that. And also the K-mean clustering reveal able to cluster the student into meaningful group that can be helpful for further action for their academic performance and for further action to be taken.
Alright, now it's time for the conclusion. So, first one, NLP regression model. We will capture non-linear patterns. We will capture complex non-linear patterns between students, attributes, and also outcomes. NLP also predicted final grades with high training accuracy, but not everything overclicking methods. Result, highlighting a need for model tuning. And also, next is training clustering. Is for segmented students into four clear groups: excellent, good, average, and also at least. It will enable educators to design targeted intervention for each group. The third one is pipeline integration. We combine prediction plus clustering into a reusable function. We also will output included predicted grade, design, performance, error, and confidence level. Lastly, for the future improvements, we would like to optimize NLP to reduce overfitting. For example, early stopping and drop off. We will also evaluate alternate model, for example, random forest. We also deploy as an interactive tool for educators. That's all from us. Thank you.